All right, we are back here on the Monday Morning Haskell video blog. We are back with our Haskellings program, and we're going to work on a new feature today, and we're going to try and use test-driven development to some degree, because that's that's a good practice to be in, especially as you work in the industry. So we're going to try to identify our problem and then write some tests for it first. But first, let's go over one quick refactoring change that's pretty important, is that previously exercise info was just a tuple of these three strings. In this video, we're going to be making our exercises runnable. We're going to treat some of them as executables and some of them merely as compilations. And so the runnable ones have to have this Boolean information added to it. So I've just made a formal data type out of this exercise info. We won't go into the details of everything that changed for that, but let's talk now about what is really going, what shape this is really going to take. So we have this this new exercise I made, recursion 1, and the objective is not just to make this Haskell module compile. The objective is to pass these pseudo tests that I've put down here, where obviously if we take the sum of this first list and this other list, we want to get these values 10 and 16, and if we don't get those, then we'll throw an error. So how do we go about doing this? And so first, let's go ahead and write some test cases. So we'll have 3 different test cases, basically taking this one exercise we've made and breaking it into 3 different stages. So we have the first stage where it shouldn't even compile. This should produce a particular kind of error for us. Then in our next case, we've made it compile, but we've just assigned an arbitrary value to it. So this should be a different kind of error. This should tell us that our tests failed effectively. And then our last stage will be, okay, we actually have, this is a working implementation of this sum list function. So let's go ahead. One thing I should demonstrate first, I think we have this run result type. I don't think it's worked very well, but so now instead of returning an exit code, what we're ultimately going to want is for our compile exercise function to return this run result. So we have, it can be a compile error, or the test failed, or we had a run success. So there are now 3 different outcomes rather than just success and failure. So that's one thing we're going to come back to as once we're finished writing our tests. But now let's go into our test file. So we have down here a few more test cases. So we have this run and failed, the first version where it won't compile, and then we have a second version where it should compile, but the tests will fail, and then this third version where it should pass, and these should all have different outcomes. Now, because they'll have different outcomes to what exists in our program already, we'll need a couple more assertion cases. So we want this is run failure output to essentially tell us, okay, this this successfully compiled, but the tests failed. So this is going to be kind of similar to our existing function here, but we're just going to have, we're going to change this. So instead of saying couldn't compile, we'll say successfully compiled. And then for the second line, so we'll say output lines 1, just to get the second element out of it. This should say tests failed on exercise. So that's our first new assertion, and then our second new assertion will be concerned with basically doing really a similar thing, except condition to saying, in fact, this should be exactly 2, I think, and it should say successfully compiled on the first one. We should say successfully ran. So that should be the prefix that we see in our final output. So those are the new assertions we're going to be using. Let's go ahead and write these test cases. These are going to be, as I said, very similar to the existing cases. We just want to provide good behavioral development. We want to provide good descriptions for what we're doing. So each of these already has an exercise info attached to it. So when running compile exercise with a non-compiling and runnable file, we're going to say, okay, well, this should indicate failure to compile and return a failing exit code. This should do what we're already doing. The exit code or the exit status, I suppose, should be a compile error, and we should have this is failure output that we normally have. Now, in the second case, oh wait, that's right, we need a before hook here. Our before hook hasn't really changed, except that we are passing the exercise info instead of separate strings. So that's basically very similar to what we had before. So even in the executable case, if it doesn't compile, we'll just say, okay, this doesn't compile. So now let's get into the slightly more interesting case. So this is going to be recursion 1 bad 2, so the second version, where it compiles, but it does not pass the tests that we wrote. So with a compiling but incorrect file. But incorrect should indicate test failures and return a failing exit code. So now our exit should be test failed instead of compile error. And instead of having is failure output, it should be, what I name it, is run failure output. And now for our last case, we do want to have some more structure again, have our before hook, and we'll say recursion good dot output, and so now it should be with a compiling and runnable file. So this should indicate successful compilation and return a success code. So the exit should be run success, and instead of having is run failure output, we should have is success run output. So there we go. Those are our test cases. We can now jump into a terminal and see if anything needs to change here. Let's stack test. Did I miss here? Okay, so utils. So I didn't make a utilities module compile entirely. So okay. So let's see the changes that we now need to make to our compile exercise function. The first is that we need to know if our exercise is runnable or not. So we'll add that fourth argument there. That was the compile error we were getting. Let's see if there's anything else that doesn't compile. Okay, so at this point, we aren't yet returning, I changed the result type of this to be run result instead of exit code. So if we go down here, we can actually start changing that and say run success is what we had in this compilation case, and then in this case, we will want our default, our already sort of failing case will have a compile error. That fixes things. Okay, looks like our code now compiles. But we have some errors in our tests. Let's take a look at those. I just need some parens out here, or some dollar signs. Okay, that's a little better. So now we should see that our tests run, but that they fail. Yeah, so indeed, our our results are a little bit different now, so let's go ahead and fix that. Several different things for us to fix by changing how our actual code works. So the main thing is we want to change basically this logic right here. When it succeeds, if it is actually executable, then we want to do something else. If it is not executable, or if it's not compiled, or if it succeeds on compilation, then we'll want to also run it. But we only want to do that if it is runnable. So there are a couple different things we need to account for here. So the first is that this argument I've been including the whole time, -o and then the executable path. I've actually removed the executables out of those previous exercises. I had the executables, but we didn't use them, and now we really don't want this argument if our exercise is not runnable. So the way we're going to do that is we're going to say let base args, and this is just going to be, you know, the first few things we have, just those. And now final args, we're going to say if is runnable, then we're going to have base args plus plus, we're going to append these, else it's just going to be base args. So that should fix our problem, should fix some of the compilations. Like if we go into our test, we'll notice that one of our previously working tests, so you know, this successful compilation case, you know, now is failing, and that's because we didn't have those arguments quite right. So let's see if we've actually managed to fix that already. Okay, so, well, we need to pass our arguments as, we need to say final args, pass the arguments that we just made to our process specification, and then we'll go ahead and see if that's made a difference here. Okay, so we see our original 3 cases are back to, our original 2 cases, I should say, are back to succeeding. And we also, you know, we do get a compilation failure on that first new case we added, but we still have some way to go. So I think it'll be useful to sort of reorder our 2 cases here. Like right now, we have the exit code of trying to compile this file. And if it fails, we just want to do the same thing we were doing before. We want to do the same thing that we've already been doing this whole time, just return that error code. Now, if it succeeds though, we might have an additional step. And so we need to ask ourselves, okay, is our code runnable? And if it is, then you know, that's good for us. Well, or at least we have to actually go in and run the executable, and then do kind of the same process that we did when it came to compiling our code. So we'll keep all this original code. We will still print that it's successfully compiled. Remember, we had that in our test case, and you know, then we'll say, you know, if not is runnable. Oh, wait, I'm gonna actually rename that. Say X is runnable. We don't want to sort of overwrite the name of that, the name of our argument. I think I might have called it is runnable in the exercise, but if not X is runnable, then all we need to do, we just do these actions that we're already doing. We'll remove the directory and then just return run success. But if it is, we have another process we have to run. So we have to go back through the same process that we were doing above. So we have to construct a new process. Do, and we have to create a specification. This is going to be a lot easier. We don't need any arguments to actually run the shell command for our executable. So let's say the specification is just shell. And then gen executable path, we already made that up above. So we're just making a shell command that is just going to run the executable path. So we can just use shell instead of process. So then we need to create our process. We're going to do the same trick here where we say we're going to modify the pipes on this process so that we get so we can control the flow of terminal output. And once again, we're going to wait for process. I need to get the output of this. Same as before, we care about the error. And a process handle. And then we'll wait for that handle. That's this guy. Okay. So let's take a look at the exit code for our executable now. Case exit of. If it is a failure, then we'll take, again, similar action that we did above. Again, we'll have a code. We don't really care too much about this code, but we'll take similar steps. So we'll say, the core of this stuff is all still applicable here. I need to fix my tab. My shift width would make that easier. But so instead of saying couldn't compile, we'll say tests failed, just like we put in our test cases. And then we'll put the file name. And now instead of checking proc standard error, we're going to check the exact standard error. Is it error or error? So we'll check the exact standard error. If nothing, we won't do anything. But otherwise, we will sort of put that out based on our config. We'll write the error code to that, and then reset our screen. And we'll just wrap up by doing everything we were doing before. Remove the directory. And we will say return test failed. So that is the failure case. And oh no, I need to indent all this again. So that's the case for exit failure. With exit success, again, you will do a lot of the similar things we were doing before. So we'll set our terminal to green, and then we'll say successfully ran. Success file name, and then we'll just return directory recursive, and at last we will return run success. All right, time to compile and see if we made any mistakes. Okay, exec scope. What did I do wrong here? Exec spec, not exec scope. Silly mistakes. Does it all work? First three cases work. Case does not work. Okay, so what sort of went wrong there? I wonder if I just returned compile error. So it looks like we have one failure case, and I think that's actually just down to put our string wrong. It should be tests fail on exercise, not test. Let's see if those work now. And okay, first few cases pass, and those cases pass. So it looks like now we are done. I guess for one more case, what we can do is bring up close out our test cases. And instead of being in our test cases, we can go ahead and do the real thing. We can look at exercises, recursion exercise, and we'll observe in the test terminal. Let's do a stack install. Recursion 1. So we see that we get a compilation error when doing this. If we put say 0, sum list of A through A's is 1. Let's take a look now. So the sums were incorrect, so we're seeing basically our error output now. And then if we fix that, so we'll say that is a plus sum is a's. Now it successfully compiles and successfully runs. So that is all for this segment where we tested executable code in addition to just the compilation of our Haskell code. Next time there are a couple more things I want to work on with Haskellings. I think one of them might be hints. That's one option we could go. The other option is going to be incorporating real proper test code into those exercises like HUnit or something, which might be a little more complicated. This might involve adding some dependencies to these files that we're compiling with GHC. But yeah, come back next Monday for that.